Hi, and welcome to season 3 of my little show. If you ever watched some of my previous seasons, or series, depending on what part of the world you live in, you may have noticed that, first off, if you have seen some of my previous ones, hey, welcome back. Unless you're having to repeat the course, then, bummer, dude. If this is your first time joining me, hi, I'm Mark. How you doing? But anywho, if you've seen season 2, you may notice it was shorter than season 1 by a lot. It's only like 7 maybe episodes I think I ended up doing. There are some reasons for that. Both of them, or however many I ended up having, the reasons there were. I think there were 2, at least, related to technical issues. Which may or may not have been due to a Windows 10 update or upgrade. If so, thanks Microsoft, appreciate it. And I'll be honest, during most of the semester I was kind of busy with
I am bidden to grant you dried fruit candies.
stuff. But for season 3, I figured I'll go ahead and I'm going to bite the bullet. I'll buy Camtasia, so hopefully it'll start looking a little better. Another change I'm going to make is, in the past I would do 2 topics, one from General 1, one from General 2. I think now I'm just going to start doing 1 topic at a time, especially now that I've got to do more post-production than I used to. Besides saying, okay, we're done, Google Hangouts, upload it. So, also too, if I'm only going to do 1 topic, maybe I'll do organic now and then. I don't know, we'll see. What do you want me to do? Go to the channel and leave me a comment or shoot me an email. All the contact info stuff, I'll tell you where to go. You'll be able to find it because you're smart. You're taking Gen Chem or organic, you're smart, trust me. All right, don't let anybody tell you different. But anyway, so I figured we'd start just talking about some General 1 topics, from Chapter 1, because if you're watching this as soon as I make it, that's probably about where you're at. And I do try to film these and talk about a topic where you're probably going to be in the semester, just in case people are starting to watch these on a weekly basis. But we'll talk about some of the common chemical terms that students sometimes get stuck with as they start to take all this chem stuff. And we'll start with physical properties and chemical properties. So a physical property is one that you can measure without changing its identity. Whereas a chemical property, if you're going to measure it, you're going to have to change its identity. So, for example, let's say you want to measure the volume of Pabst Blue Ribbon. Pabst Blue Ribbon, the #1 college choice for college students everywhere, because they're too dumb to know any better and too broke to care. Let's say you want to measure 100 milliliters of whatever this stuff is. Some people call it beer. And so I will just... And yeah, I left it open, so hopefully it'll take care of some of the fizzing. So yeah, I just measured 100 milliliters of Pabst Blue Ribbon. So measuring that 100 milliliters didn't change its identity, whether you wanted it to or not. So yeah, volume is a physical property. Mass is another physical property. I have my little kitchen scale or balance if we were in a laboratory. All right, I can turn it on. All right, I plop that onto the kitchen scale, and it says that it is 489 grams. Yeah, because I forgot to tare it and forgot to take the mass of the cup first. Yeah. Thought I could do it in one go. Oh, really wish I'd done it in one go. So God, there's some residual. Oh. This won a blue ribbon at one point. You know, I always like to think that the real prizes was gold, silver, bronze, and blue ribbon was just a participation ribbon. But no. Anyway, so you weigh the cup now. And it looks like it weighs 396 grams. So you weigh by difference, as you may do in a laboratory. You end up with 93 grams. But weighing the beer didn't alter its identity. So mass is another, man, it's hitting me in the stomach right now, another physical property. I'm out of practice drinking crap beer, I gotta admit. Yeah. So yeah, those are physical properties. Right. For chemical properties, let's say you wanted to see whether or not beer was flammable. Because again, you're too dumb to know any better and too broke, hopefully not too broke to have insurance. But you know, you take, so yeah, you light it up and say, hey dudes, watch this, and nothing happens. Because beer isn't flammable. Yeah, alcohol is flammable, but this is mostly water. This is mostly water. So, but had it been flammable, I probably would have gotten a lot more, or I probably will get a lot more hits for this video. I might even make it to the Huffington Post. But had it been flammable, you know, like gasoline, you know, you strike a match, light gasoline, house of fire. Yeah, it burns, or wood burns, but you know, the process of burning something is going to cause this identity to change. That when that gasoline goes up in flames, it's no longer gasoline anymore. Ideally, it's carbon dioxide and water, which you may talk about in a later chapter. They're called combustion reactions. But one thing to keep in mind is just because a test was negative doesn't mean that you weren't testing a chemical property, because had it been positive, you would have seen a change in identity. Right. So those are chemical properties. The you know, again, physical won't change the identity, chemical will. So a couple of related terms are physical changes and chemical changes. So physical changes, those changes can occur without changing the identity. Chemical changes, those changes will change the identity. So notice that both of them have similar definitions. Both the physical changes, physical properties, there's no change in identity. Chemical change, chemical property, both of those involve a change in identity. So some common physical changes are, you know, freezing and melting. Again, we'll use the beer example because why not? That gets kids into the attention, doesn't it? I don't know. Yeah, you have a beer, you didn't buy it in the freezer, you bought it, whatever, it was warm, but you really want to drink it. So you stick it in the freezer, wait a few minutes, or you plan on waiting a few minutes. Turns out you forget about it, and it freezes. So the identity hasn't changed. It's still beer. It's just now solidified beer, a beersicle, if you will. But a chemical change, the identity will change. So again, when you burn gasoline, it's undergoing a chemical change. It's going from gasoline to ideally CO2 and water. Rusting is another example of a chemical change. You know, you take a piece of iron, when it rusts, it's no longer iron. It's an iron oxygen compound, which you'll see is more or less another combustion reaction. Notice that chemical changes and chemical properties, they both involve some type of chemical reaction. So that's one way to kind of help you figure out whether it's physical or chemical. If it's undergoing, if it involves some type of some chemical reaction, like combustion or whatever, it's probably a chemical change / chemical property, whichever one you're looking at the moment. So finally, a couple of other, another pair of terms, if you will, that students tend to get stuck on a bit in the first chapter. Excuse me. The Paps is making me burp. Is intensive properties and extensive properties. I'm not doing another take just because I can. Yeah, that was a nice thing about Google Hangout. I could just, ill or will, just forget it. We'll do. Fun fact, I've already done this more than once already. But no more. I'm too deep now. But intensive properties, those are properties that you can measure, or those are properties that when you measure, it doesn't vary with amount. Or they're properties that won't vary with amount. An extensive property, on the other hand, will vary with amount. So, going back to our beer example, I measured 100 milliliters of beer and it had a mass of 93 grams. If I want to measure some more beer, over here, Metal Gear, let's say you measure up to 200. Yeah, more beer changed the amount because volume is an extensive property. Yeah, which again, don't because it's a chemistry class. Don't let the chemistry throw you. Yeah, more volume changes the amount of the stuff. So yeah, volume is an extensive property, and if we measure it on the balance again, you get a mass of 587, and I said it was 396 to begin with, so 191 grams is what that 200 milliliters of beer weighs. So again, mass is another extensive property. The more stuff you have, the more it's going to weigh, which you kind of knew that coming in. You just didn't know it was an extensive property. So again, don't forget about the stuff that you knew coming in, right? But if you divide the mass by the volume of those, you can calculate the density. If you do that with our first trial, if you will, you get a density of about 0.93 grams per milliliter. If you do that with the second trial, you get about 0.96, which is within the reasonable error of a measuring cup and whatever error is on this kitchen scale I'm using. So yeah, they're within reason, pretty much the same density. So density is an intensive property. It doesn't change with amount. And you'll notice too, a lot of intensive properties, but not all of them, are ratios. This per this, because so those aren't going to change with amount. So water, it has a density of 1 gram per milliliter, no matter how much water you have. A cup full, 100, 200 milliliters, swimming pool full. No matter how much you have, it's always going to be 1 gram per mil. So that's one thing to think about when you're trying to determine whether it's extensive or intensive. Just imagining having more of this stuff. Is the unit or property or whatever you're looking at, is that going to change? Or is it going to stay the same? Like concentration. If you have a solution of or beer, whatever this is, do they tell me what the percent? I don't know. We'll say it's like 3 or 4%. Yeah. No matter how much you measure, the percent alcohol isn't going to change. Concentration. That's another intensive property, and you guys will learn more about that at a later chapter when you look at this thing called molarity. So, that's that'll be it for today, this week. Again, if there's a topic you want me to cover, then you can just shoot me an email at the address below, assuming I know how to put in an address. Or you can go to my YouTube channel and just put it in the comment section. I'm not going to do comments for individual videos because that will be a headache to try to look at all those comments. And And also, too, if you're one of my students, and you probably are because most of the people who watch these are my students, don't send me an email there at my Gmail account. Just send it to me at my work account. Just try to keep all that stuff there. But for anybody else, you can email me at my public email address. All right. And for more doings of transpiring, you can check out my website, which is here or nowhere, because I'm hoping I figure out this Camtasia thing. But anyway, that'll be it. See you guys next week.